Yeah, hi. Welcome to the third video of this ZEC series. And this video and the next video are going to be the most important videos according to my thoughts. And the reason is because we are going to discuss some core fundamental topics here. And for the newcomers, or obviously for the old programmers, they already know about this. And yeah, so this video will be basically going through conditional statements and functions and loops. So these three are basically fundamental blocks. And the reason why I say this is the most important video of the series, and especially to the new programmers, is because when I used to code like in school and assembly, the very first thing we used to do is draw out a flow chart of a program. And in that flow chart, you would typically see a start of the program, and based on certain conditions, your program will behave. And based on then there will be one more conditional statements, or let's just say one loop where it'll go back to do certain kind of operation again and again until it gets a desired value. And then again continue with that same standard approach, which is based on some conditions, it'll behave in some other way, and just stack up all of this and build a complete program. So and assembly, and that is that flow chart is basically a foundation of like any kind of program, any kind of computer program. You can basically convert it into a flow chart. And if that flow chart is essentially a bunch of if like conditionals, loops, then I think the this lecture is the most important one, especially for new programmers. And for old ones, yeah, I don't have to tell you guys. So let's get started with this video. So uh, just so I have a project there. Oops, edit. Let me edit. Yeah, sorry. So I have this project here, and so this is the standard ZEG project with just an hello world, and yeah. So let me just remove that. So what are we going to discuss is basically let's start with conditionals. So as mentioned, conditionals are basically you make the program behave on certain conditions. Like if the condition is like this, act in this way or do some this operation, whatever operation you want. So conditionals here in ZIG, we use if statements, right? And so your syntax will follow something like this. You will have if, and then you'll have this block. Under that, you'll add your conditions, and you can use a bunch of comparison operators, which is equal to. That means your left hand side is equal to right hand side, greater than, which is your left hand side is greater than right hand side, same, and just combination of both of them. There's And then there is one which is like not operator. So something like this is not equal to your left is not equal to your right. So basically you can use this comparison operator, and you can write a simple conditions. Let's just say we have something called as const like foo, which is, let's just say, a U8, and let's just say it's basically 1. And now I want to print the state. I have this if condition. So my program should print hello world only when foo is equals to 1. Okay. So it should print only when if the foo value is 1. Now this foo value can come from other blocks. Basically, if you remember what I said, we are going to you can write a computer program by stacking this conditional statements actually. So let's just say this foo is not declared here, but coming from some above value. So I can basically manipulate my program to do certain operation based on the value of foo. So that is what your if statement does. So basically, let's just say if I just want to print something and foo is to, oops, sorry. Let's just say I just want to print foo, and I want to print foo only when foo is 1. So here in this, according to the statement, we should see foo as 1. So if I just go this and zig build, and let's just run this uh, dot slash checkout then slash electricity. So do you see foo value is 1? Now, if I just do here, come here and modify foo value to 9. So now let me show you the output. So I'll just do a zig build again. And you see there's no output here. So what my program did is we are only printing the statement if this condition is met. Okay, so that's the and that is our that is the condition which we set this, and this condition will come handy when we look into loops as well. So I just want you to just understand, like every any program can be broken into a certain like set of conditions, and you can basically write an entire computer program on that. That's why this is very important. And here you can there is also a else statement. So basically, what you can do is if foo is equals to 1, and if this condition is not met and you want your program to behave like, oh, if this condition is not met, let's be handle that in a separate behavior. So what you can do is basically add a else statement which will do like, okay, if this foo is this if this will print only when foo is 1, but what if this foo is not 1? So let's handle that in this operation. So foo actual value, and also like let's something like foo is not 1 and foo actual value is this. So now you see that we actually see, okay, foo is not 1 and foo actual value is 9. That's why that condition was not met, and we can handle this accordingly. So that is if conditions and if else statements in Zig. And one of the things that is very important to note is usually what happens is um this thing, this equation actually equates to something called as Boolean. And Boolean are basically two values. It is either a true or either a false, and nothing, and not anything. I mean, no, other than this two, it cannot be anything. And what other languages allow is if if it either is zero or something like if it's zero or zero, so it'll treat it as false, or if it either is something like some kind of data or some kind of integer, like if it's some other programming language, there are certain programming languages that allow that if it's something like two, it will actually treat this as true statement. You see, there is actually no condition here, but it'll treat that since there is a data present there, we will assume that as a true statement, but that is not the case with Zig. In Zig, this should always equate to a Boolean or something like this should always be a Boolean value. So this equates to a Boolean value. But here I can actually also write something like if it's true. And since this is always true because I just showed it's true, it's gonna, if I just compile it, it's gonna print as foo value. Like it's gonna print this value. And it's like all foo always, let's just say. And this is gonna stay same without like, and so if I just show you this quickly, it's going to be foo always. And now this typically equates to there is no need of this else statement because this is always going to execute, and this else statement is never going to execute. So this becomes a stale code. Like stale code is something that's never gonna, like your program will never enter into that cycle. And this is the case in when it's always equals to, like when if it's always true. But my point is here you cannot insert something like one. Now, if you are coming from some other language, you will see that uh, they allow you to insert data types, but that is not the case with Zig. You see that? You see it threw an error, and it threw that error that it expected a bool, and but it found a compile time in. So here it can always be a bool and not any other data type. That's one of the important things that you have to remember. And yeah, that's all about like condition statement. This is the condition statement. This is one of the important thing when you're learning to program for the very first time. And yeah, that's all. So let's move on to the other thing. So since we already have seen conditional blocks, let's now look into repeating operations, which is loops. There are two types of loops, while loops and for loops here. And we'll just go through the syntax and we'll just talk about what does. So by the name itself, loop, it means you are repeating an operation again and again. Now there are two things that come into like picture. until when do you want to like repeat this? Until when do you want to stop? Like, what's the thing you have to stop? Like, you have to stop. You cannot again and again do some operation in a sane program. You can obviously do it. I'll show you how it's done as well. But any other sane program will want you to stop that like repeating operation. If you remember the flowchart example, we repeat an operation to some point until we get a desired value. That is that desired value is our condition. And so let's just say it starts. So the syntax starts as while. So while we have this condition, this is not actual syntax. I'm just writing it. So this is some condition. You do some kind of operation, and now what happens is basically. Uh, so I can do some. Let's start with the very simple thing. So since this is a condition, and if you remember in F we talked about they have to be something like Boolean. Let's just say while it's true, I'll just print something. Uh, Infinite loop. I'll show you in a sec why I said it's an infinite loop. Uh, right? And you see, the program is not stopping actually. It's again and again. If you see this part, it's again and again printing. And if I just pause it and scroll it, there's a lot of infinite loop printed. And this is the end. It's again and again printing it. And that's because, okay, to stop it, just press, okay, oops. Let me just stop it here. Control C, interrupt the program. So now we know that, so this is the condition while true, we are again and again repeating it. Now this can be useful some for some programs. Basically, if you want to crash something, just load in memory, take memories, and just again and again do some certain operations, but not much in for useful programs like day-to-day programming. You need it to stop like act according to certain conditions, and so that's where the syntax goes for, like this. Basically, let's just say I want to print number 1 to 100, right? What I can do is basically I can have something like a const, like let's just say index, and it's gonna be a U8. And let me, since I want to print, right? Okay, let me just say number. So this is gonna be a U8 number. So I just want to print this 1 to 100, like 1, 2, 3. I'm just gonna do something like this, and let's just start with 1. So what I want to do is while this number is less than equals to 100, basically I want to add a condition that I want to use this loop until this number is less than equals to 100, and what I want to do is basically print this, and I'm just gonna do this, and just gonna print the number, not any text here in new line. And what I'm going to do is I'm going to do this. Now, what will happen? What do you think? So let's think procedurally, like one by one. So we initialize a number with 1. And while this number is less than 100, which is true, what we are going to do is we are going to print the number. If you see, this will, like, what is the assumption? Do you think it will run indefinitely, like forever, just like the last one, or will it like print 100 times? What do you think? So I'll show you why it will print indefinite. You see, it's keep on printing. Okay, have to stop here. So now what's happening is this condition is always true. Just like if I just replace it with true, both of them are basically equal. So for us to print this, what we have to do is we have to increase the number first of all, because we wanna basically we wanna like print 1, 2, 3. So we have to increase the number every time. And now what will happen is there will come a time when the number is 100, and then what we'll do is we'll like there'll come a time when the number is 100, and we'll print that number, and then we'll increase the number by 1, and then the number will become 101. So when the number becomes 101, this loop will actually break because this condition is not satisfied. This will be like, this will equate as a false statement. Till 100, this will equate as a true, like a true statement. But after it reaches 101, this will equate as a false statement, and this will stop. So this way, we can actually do us like this operation that is printing 1 to 100. Weight cannot assign to a cons. Yeah, this number is changing. If you see, if you remember, cons cannot be changed, and here cannot be muted, and here we are mutating it. So this should be declared as a like var, and then should not throw any error. And here, what we do, see, what it did is it printed one like 1 to 100 here in this order, and then the program stopped. If you see, the program stopped at 100. So this is a standard while loop syntax. What you can do is this thing is actually called as a continue expression, and you don't need to write this continue expression inside it. So you can what you can do is basically have this and write a colon. Oops. So you can write a colon and add this continue operation in this bracket, and this is basically the same. And this way, it looks a little clear in a sense that you can read same output. You can read the entire code. You can understand, okay, this is a while loop. That is, uh, we are we are gonna loop, and this is the condition. It should stop. Number should be less than 100, and so and this is the continuous expression. We are increasing the number by +1. We can also increase the number in like multiply by 2, and then we'll know, oh, so this is going to increase the number multiplied by 2, and then we'll be like working with the number inside, like performing some operations on the number inside. So this is more easier to understand in a single like you can understand, you can read it when you get inside the while loop, but I feel this is more easier here. So we'll mostly like you can use anything you want. So this is the while loop. Just like the while loop, we have something like a for loop. So yeah, so this was a while loop. So now we have one more loop, like one more way to like loop implement loops, and that is for loops. So let's just say we have something like an array, and we'll call it a hello string, hello, and this will be something like you remember, it's gonna be, we'll just let it sell in friends. It's gonna be this, and then it's gonna be, let's just say something like hello. Okay, sorry. Yeah. So this is the array we have, and now what I want to do is I want to basically print each character in a new line of this. Now, one of the solution is basically let me just print them as something like I can basically print them something like this. I can have something like hello 0, which will print h, and then repeat this, exactly. But that's a better. So we can. Do you see this operation is basically repeating an operation? What if I'm printing a new line? So we can also like implement loops here. Same, we can implement the while loop here, but here we'll see how do we do that with for loops. Just like while loops, for loops also allow us to iterate like to a repeat an operation. What happens here is basically the syntax goes follow like this. So we have a for, and then we can pass a data type that has the iterate like capability to iterate. When I say iterate, that means you can traverse through one part to the next one easily with like just jumping indexes, a jumping location like an array, which I mentioned, they are contiguous memory. You can iterate over each element one by one. So this takes a data type like that. Let's just say we pass hello, and now the syntax goes like this: is once you pass this, as I mentioned, it has the ability to iterate. What it can does is it can I'll write this, and inside this I can like write something like this item. This has the and I'll have the brackets. Okay, so what this item is basically, when what for does is it iterates over this, and then when it iterates over it, this syntax is used to capture that value. So when it we pass this to for will iterate over it and then it will capture this. So here this item can be h and then like one by one iteration. It'll be e, it'll be l, it'll be then this l, and then it'll go to o until it reaches the end, and the for loop will stop. So now this is like what the for loop does. And if I can do something like, let me just print this. Uh, what I want to do is I want to print the item, and here I'll just pass the UDF encoding like as my basically format specifier. And here just clear it and zig build it. And here if I just run this, you see what happened here? What happened is the for loop went through each item, which I mentioned before, and the item here captured that, basically captured this value. And then we are just printing this value. So these for loops are very handy when you are iterating over some data type, moving over, scanning a data type or going through all the values of a data type that has gives you an iterator. And so now let's look into the different one of the variation of a for loop that we can use, and that is basically what if I want to print this numbers one by one, and also I want to print the position of this number, like at what position they come. So what I can do is basically I can access, I want to access the positions, right? So what I can do is I can iterate over numbers, and I can just start from here. So I want to say it starts from the 0th index and I want to access each position, right? So I have to capture them. So in the capture block, what I want to do is I want to capture each item as a number and each position as an index. And here I can perform like a trade over it, right? And here, one of the things that we should know is this IDX is going to be of data type usize. So if you ever want to perform certain operation and int operations, it's better you change the data type from usize to integer, or yeah, whatever you want. So now, let's just say I want to print something like, I want to print, I want to print the number, like each item, and I'll print the position, which is basically going to be the IDX. And here, what I'll do is, I'll do zip build, I build, and here I run. So do you see? I basically am able to iterate over each item with the each position. So this code IDX lets you access each position. And now, but if you see, although you see them as 0, 1, 2, 3, 4, yeah, it's not a integer, it's a data type usize. You just have to remember this. And yeah, that's it for the this other variation of for loops. Basically, you can access each index of the data type you are iterating over. So that's done. So the other thing that we are gonna come use is basically functions, which we saw uh, here this part. So even before explaining you what is a function, we have already been using functions from the very first lecture when we printed hello world. Function is basically this thing, line number 3, what is returned, till line number 20. So functions are basically an abstraction over certain operations. So let's just say this is what this program is doing, that is printing 1 to 5, right? What I can do is, instead of writing it here, what I can do is, let me just delete this and let me create a function. So it starts with fn keyword function, and let's just say some task. Okay, print numbers. And here, since I'll do this since we don't need any inputs. This is where you pass inputs. So if your function needs some input, you will pass it here. So and here you write the return type. Since we are not returning anything, we'll just use it void. And for now, we'll use an exclamation. I'll tell you. We'll go over through this next lecture. So here I'll just paste the whatever thing we cut, like copy paste everything, right? And now what I want to do is, this is the main program. If I run there's nothing here, so it won't execute. So what I'll do is basically call this print numbers function here. And now if I run this, if I build this first of all, okay. Uh, oh, okay. It's because this is gonna throw some errors, and we have to try. So what I'll do is basically for now, let's just say I do something like this. Okay. Forget about the try statement for now. Okay. Forget about the try statement. We'll discuss about the try statement later. What I want to show is this. You see, this is the exact same output what we got without this. So to summarize, functions are basically you pass some inputs to a bunch of abstracted code. Okay, bunch of abstracted code or certain operations, and you expect some output. And this output can again be passed as an input to some other function, but this is what it does. Basically, this the only thing you can write your program without functions actually, but you the we there's this concept of modularity. Basically, if I want to use this print numbers function again in a code, okay, sorry, not print function. If I want to use this thing, this line of code which I wrote, like this thing, again in my piece of code, like program, do you expect me to write it again and again? No, right? The best way is to abstract it into certain block. Let's just say a black box. We put it in, we push some, and we make it such that it takes some input, gives me some output. Although in this case it returns zero, it does not return any thing, but just assume it can take some input, can return some output. Okay, so this is the abstraction we are doing, and we can reuse it again and again, and that's all to function. Function is basically it's like a wrapper over your code, and so that you can just use it again and again, or you can just pass it as a like you can make it look clean. So if I see something like this, like I'm concerned with the main function. All I see is it's trying to print the numbers, and then what is print numbers, I can just go to jump to definition here, and I can actually see what print numbers does, and that way I can understand, okay, oh, I'm going to print numbers, or I can do something like there will be I can add some more functions like, okay, play with the like multiply those numbers, uh, like multiply numbers, so I'll be like add those numbers. I can have multiple functions like this, and I can see basically like I can get the flow of the program. So this programs print the numbers flow first, and then it multiplies them, it adds them, and yeah. So they are basically functions are basically just abstraction version of your operations or code, and they are nothing else. They can take some inputs here. I can pass some inputs like foo of u8 like this. So this is basically this is how you pass an input. You basically say something like it's gonna print foo. Yeah, foo, and that's all it's gonna do. So here the item will be foo, which will be any number we pass. So here we can do something like 10. So if I just run this after building, I'll see an item equals to 10 first, and then yeah. So that's all it does. So basically, like functions and an abstraction version. So coming back to my original statement, is you can write an entire working code, like or you can represent any piece of code as a combination of conditional blocks, repeating operations, functions, and obviously derivatives just to store values. And this is all you need actually to write code. That's all. And that's why this is one of the most important thing. Anything other than this is to make the program like either memory efficient or like fast, make it fast, or make it like easy to find errors and all. But if we are talking about a bare bone piece of code, this is all you need. And I hope uh, this lecture like clears the syntax, and if you're new, you understand what conditional blocks, repeating operations, and functions are. Uh, in the next lecture, let's go over through this thing. We'll understand why did we add try, and we'll also understand what does this exclamation and void means. So yeah, I'll see you in the next lecture. Thank you.